any one of these panelists could speak for more time than we have allotted for the entire panel on the subject we have to discuss, which is how to think about the next generation of energy supply, from coal, from clean coal, from nuclear powers, from low-carbon powers, from all the rest.
This, unlike other kinds of things that we're doing here, there's actually multiple storage mechanisms that work over multiple length scales and time scales. To make this as brief as possible, a good site gets better over time. The risks decrease at a site through time because the pressure decreases, and if you choose your site well, you actually bind the CO2 in many, many different ways. There's a lot of projects out there. I keep hearing from people this is some sort of untested technology where we don't know anything. Nothing could be farther from the truth.
Thank you, Jim. And let me just spend a minute on why we can have a next wave, and it's because the current 104 operating plants are actually operating so well. And I think you probably know we have 104, which make up 20% of our current electricity, 70% of our non-emitting. What I often hear is, why don't we have 80% of our electricity like the French do? And what I would tell you is I believe we operate the best, most reliable, safest plants in the world, and we're bigger than the French and Japanese programs combined right now. We produce 800 billion kilowatt hours out of our nuclear plants. That's more than France and Japan combined.
I think that's an important issue, but I think for people in this room talking about low carbon generation, the more important issue and the more important goal that we should all dedicate ourselves to is the clean energy standard, transforming the renewable energy standard into a clean energy standard.
What's striking to me is we heard first from Julio Friedman that carbon capture and sequestration could be done, and also that it had to be done, and that it should be thought of as an emissions control technology, not a coal technology. We heard from Mr. Fertel that this also could be done, but not in the new generation of nuclear, but not in the next 10 years. The challenges would be infrastructure, and also would be financing. We heard from John Gilwan that there was an exciting new prospect that could simplify the process in many ways, and we can hear more about that. And we heard from David Crane about the importance of national clean energy standards. The first question I'd like to ask you for, and I throw this to anybody who wants to answer, is should those of us in the lay public and the expert public here, everybody here is an informed public but not as expert in your respective fields as you are, should we think of your four approaches as being a complementary portfolio working together, or should we think of tensions within you?
We simply do need it all, and this is something that Mr. Fertel said earlier, which I agree with.
The other question I have is actually to re-ask the question of this panel. That is, will it get built?
I think it's more that right now, I think that the one thing that the both parties have in common with each other, a complete common interest, is in re-electing incumbents. And I think that at some point that as they round the bend into the late spring, early summer, they're going to say, what are we going to go say we actually did for the last 2 years in Washington other than fight each other? So it's not an era of goodwill. I think it's an era of self-survival that I'm hoping that we can bank on.
I just think that one of the things that would be helpful for political feasibility, either in the near term or longer term, is a better appreciation of the subject matter. I don't mean nuclear per se, I mean electricity and energy. Everything in Washington is easy because you don't implement much of it. Okay, it's a real challenge when you're out there trying to build something and operate it. And that's one of the things that we see over and over again on nuclear right now.
Sorry, just one last quick point on that. John's technology is only one of which potentially can handle the waste issues. There's many of them out there. All of those require some sort of investment in research and development, demonstration, deployment. In the meantime, dry cask storage works. Dry cask storage works. It's worked for a long time. It's a marvel of technology. Stores nuclear waste indefinitely, perfectly fine. And in that context, Yucca Mountain, I think personally, is not a technical barrier to this. There are many technical ways to proceed.
Our other category of questions involves carbon capture and sequestration, and they are, excuse me, please discuss the costs of it and the timing. If it's being done, why aren't we doing more of it now?